Let's take a look at how to name those compounds, ionic compounds, that have metals that do not form just one type of positive ion. For example, copper is one of those transition elements, and it can be a +1 or a +2 ion. So when we try to figure out the charges on these, we cannot just go directly and say, oh, copper is a group so-and-so, so it will have this charge. We cannot do that directly. To determine the charges on the metals, on the positive ions, we have to look to the nonmetals first, because that will determine the charges on the metals. Let's look at this compound. I have copper, and then I have sulfur. We know that sulfur always forms a 2- ion. We know that all nonmetals have a single ionization state. They only form one type of ion, and sulfur will form a 2- ion. Now, because I only have one atom of sulfur, that means I have a total charge, negative charge of 2-. Copper, I only have one copper, which means that my total positive charge, which has to balance the negative charge, which is 2-, has to be 2+. And that 2+ only belongs to the one atom, because I only have one atom of copper, which means that copper also has to have a 2+ charge in this case. Okay. Now that I determined the charge on the copper, I named this just as I did the previous examples when I have metals that are form just one type of ion. But we have to do one more thing. We have to specify the charge of the metal in Roman numerals in parentheses. So for this copper sulfide, I would start by writing the name of the metal, which is copper. However, because copper can be a +1 or +2, I have to specify the charge on the copper for this molecule. And we determined that it was a 2, so we put a Roman numeral 2 to specify the charge 2+, and then we write sulfide just like we would for a regular ionic compound. Now let's do the next one. We have lead. Once again, lead is one of those ions that doesn't form, all of these will be. So we have to determine the charge on the lead. And we look to the nonmetal first. We know that oxygen also forms a 2- charge. Because oxygen forms a 2- charge and I have 2 oxygens, my total negative charge has to be 2 times 2-, it's 4-. Now because the positive charge has to be equal to my negative charge, I also have to have a +4 positive charge. But because I only have one atom of lead, that means that all that positive charge belongs to that one atom, which means that the charge on the lead has to be 4+. Now when I write the name, I will write the name of the metal, so lead. And I have to specify the charge on that lead in Roman numerals in parentheses. So it's got a charge of 4. So this would be lead 4 and then oxide. Now let's move on to the next one. I have 2 different compounds of iron, so let's figure out the charges. Now, as you can see, they're not the same compound, which means that the iron will have different charges. Let's look at the first one. Once again, we look to the nonmetal first. Oxygen will have a 2- charge, always. That means that the iron, I have one of each, one atom of oxygen and one ion of oxygen and one ion of iron, which means that to balance it out, the iron has to have a 2+ charge. Therefore, when I go to name this compound, I will write the name, so iron, and then I will have to specify the charge on the iron, which has to be 2 for this one, in Roman numerals, and then I write oxide once again. Okay, now let's look at the next compound, which is still an iron and an oxygen compound, but it will be a slightly different. It will not be iron 2. Okay, we look at oxygen first, will always have a 2 minus charge, always. That makes my total negative charge 3 oxygens times 2 minus, so each of them will have a 2 minus charge. 3 times 2 is minus 6. So my total positive charge also has to be plus 6 to balance it out. So the plus 6 charge has to be divided equally between 2 irons. And that means that each iron will have a 3 plus charge. This is the opposite of what we were doing when we were writing formulas. So if you take this subscript for the oxygen and bring it up here, it will tell you the charge of the iron. If you take the subscript for the iron ions and take it up here by the oxygen, will tell you the charge of the oxygen. Okay, so when I write this out, it will then be iron, and Roman numeral 3, because that's the charge, oxide. Now notice that these two are different formulas. Different formulas have different names. That is why it's very important to specify the 2 and the 3. We cannot just say iron oxide because they are 2 different compounds. And if I were to tell you, oh, go get iron oxide or write the formula for iron oxide, well, which one? Okay, because there's 2, and we have to specify that by using the Roman numerals. Let's go to manganese. Look at, there's 3 oxides of manganese. So let's look at which one they are. This has a 2 minus, oxygen has a 2 minus charge. So manganese will also have a 2 plus because I have 1 atom of each, or 1 ion of each, so 2 plus and 2 minus. That takes care of balancing the charges. So now when I write this, I will write manganese. And then I have to specify the charge, which is 2, manganese 2, oxide. Now let's go to the next manganese. See the similarities? These are similar and these are similar. So what do you think the charge on this is going to be? Okay, so let's find out. This will be 2 minus. 2 times 3 is 6 minus. My total positive charge has to be 6 plus, divided equally between 2 manganese. Each one of them will have to have a 3 plus, just like the iron up here. Therefore, the name of this compound should be manganese. Then 1, 2, 3, Roman numeral 3 to determine the charge, or to specify the charge, oxide. Well, let's look at the last one. Okay, we have oxygen. Once again, oxygen has a 2 minus charge, which means the total charge here is minus 4. But the positive charge has to equal the negative charge, so I have to have plus 4 total for a positive charge. I only have 1 atom of manganese, however, so all of that positive charge has to come from the 1 ion of the manganese, which means that manganese here has a 4 plus charge. Okay, so when I go to write this compound, I'll write manganese and then a 4 for the charge, oxide. Once again, notice that if you were to just write manganese oxide, you would not be specifying the correct formula. These are 3 different compounds. They have different characteristics, and therefore we have to specify which one it is. Let's look at the last 2. I have, once again, I always look at the anion first because they always make the same ion. Chlorine always has a minus 1 ion. And because I have 1 atom of each, the minus 1 charge has to be balanced by a plus 1, and that will be the charge on the copper. Note the difference between this one and the one up here. Here is copper 1, here's copper 2. And therefore, when I write this compound, this formula, I will write copper, and then I have to specify the charge on the copper, copper 1, and then I write chloride. And then lastly, when we look at manganese and the nitrogen, once again, we look to the anion first. Nitrogen is a group 5, so it will have a 3- charge. And because, once again, we have 1-to-1 ratio here, all of my negative charge comes from one nitrogen, all of the positive charge comes from the manganese, and therefore the manganese will have to have a 3+ charge to balance that of the nitrogen. And therefore, when I write this name out, I would have to say manganese, and then 1, 2, 3, Roman numeral 3 for the charge, and then nitride for nitrogen, nitride. I cut off nitrogen and I add IDE. Okay, this is how we write compounds or names of the compounds, ionic compounds, where the metal does not just form one type of positive ion, but several. We have to specify it. We write them the same. The only thing that's different is we have to specify the charge in Roman numerals in parentheses.